Let's now talk about sniffing and the tools used for sniffing. The word sniffing means that you are allowed to capture data as it is transmitted over the network. Sniffing can be used by network professionals and security officers to diagnose the network issues, to identify the malicious traffic, to identify the abnormal conditions that the network may be passing through. It is used also by malicious users to capture unencrypted data, such as usernames or any transmitted data over the network. Once again, sniffing is like port scanning. The difference between sniffing by a legitimate user and sniffing by an attacker is the permission. The permission is the way that you identify yourself, either as a security officer or an attacker. Sniffing is a way of passive attacking. It breaches the confidentiality of the data. It does not cause damage, direct damage to the integrity or the availability of data, but it breaches the confidentiality. Any passive attacking is always a way or an introduction to the active attacking that follows. So, any attacker starts by sniffing, by port scanning, by reconnaissance for the network, then it moves to active attacking by damaging or by denial of services or by losing data or other ways of active attacking. TCP dump is a software that is free to download from the internet. It's a very famous and well-known sniffer software. It is used with the libpcap packet capturing library. TCP dump has also been ported to Windows as WinDump. It's a simple protocol analyzer. It captures the packets and says that this is a TCP packet, this is UDP packet, this is DNS, this is SMTP. It can analyze the protocol used to send this packet. It tells you whether a DNS packet is a query to resolve an A record, I mean a website, for example, query from a client to resolve the name of a website into an IP address, or a name server response that sends the IP address to the same client that was requesting the domain name. The TCP dump is command line interface. This is the drawback sometimes, that some people do not use it much. You can request more packet information, more information about the sniffed packet with the switches -v, -v, or -v. If you use -v, then you are requesting a certain type of information. -v, more types of information and more quantity of information about this packet. And -v says that you are requesting more and more information about this packet. Information in terms of protocol, data, source IP, destination IP, source port number, destination port number, and such information. Let's have a look at an output of the TCP dump. We can see here a packet at the first line that is identified by the timestamp ending in the number 6, then the source host name, which is ping.net, then a greater than sign, then the destination host name, which is myhost.com, followed by colon, then the type of protocol used to reply to this packet, which is ICMP, which says that it is an echo request. This is an echo request packet sent from ping.net to myhost.com using the ICMP protocol and using the don't fragment flag. The next packet is the reply. It says that myhost.com is sending ping.net ICMP echo reply with don't fragment flag. The next is log.net sending syslog.com, log.net using port 3155 and syslog.com using 514. And this type of packet, the source is log.net, the destination is syslog.com, is UDP protocol, and the size is 101 bytes. The last one is sent from send.net from the port 32938 to mail.com on port 25 with the SYN flag and with initial sequence number, that is 248631, and end sequence number 248631, and with size 0 and with the win value 8760. These are the details that can be shown over the TCP dump for a certain packet. This is the header details of both the IP and the TCP protocols for such packet. The TCP dump by default only reads the first 68 bytes. This is by default, but it can be increased. How? You can specify the switch -s followed by the number of bytes you want TCP dump to read, which can be more than 68 bytes. You can say, for example, that you can TCP dump -s 1500 if you want to capture the entire packet, because most of the TCP packets range in size of 1500 bytes. This is another example of the TCP dump output. This is a complete port communication that starts by connection establishment, SYN, ACK, and data transfer in the box in the middle, and then connection termination, FIN, ACK. This is a sequence of communication happening between two machines, starting by the three-way handshake at the first box, then data transfer at the middle box, and then finally connection termination by the four-way handshake at the box at the bottom. Now we can have a look at the Wireshark. Wireshark is a very well-known packet sniffer. That's a sample of the output of Wireshark. Let's analyze it together. It starts at the left by the number of the packet number 1, 2, 3, 4, and so on. Then the timestamp of the packet, the time at which the packet was captured. Then the source IP address of the packet, 10.1.50.134, for example, for the first packet, and the destination IP, which is 64.12.26.36, and then the protocol used by this packet, and then some information about this packet, some data from inside this packet. We can see here a series of packets that were captured, that were displayed by the sequence number, the timestamp, the source, the destination, the protocol, and some information. In the middle box you can see some of the data from this packet that can be displayed, and in the last box you can see more data. In the middle box the data are related to the data link layer headers, the frame, the Ethernet, and such headers. And then at the end, the bottom box, you can see some of the binary data of the included message inside this packet. Before we end, we can have a look at how Wireshark is installed and how does it work. We can here try to install the Wireshark software on this machine and try to run it together to see how simple it is and how easily it can sniff some packets from the network. The installation is very easy and very straightforward. It does not need any sort of experience. And then we can move to the usage of this Wireshark. Wireshark is free to download. Wireshark is educational, very friendly, and very very simple GUI, geographical user interface, that can be used by anyone to sniff packets from any network. Wireshark can sniff packets among different machines and show their information, source IP, destination IP, source port, destination port number, size, and some information from the message included inside this packet. Let's keep recording the installation of this software and see how it is run on any machine that can download it. This is how the installation ends, and we can now run Wireshark. Here Wireshark is recognizing the cards and the wireless cards inside the laptop. It may ask to download some updates. This time may be depending on the speed of network you have. After Wireshark runs, we can here find an image like this that says that it has captured some packets by timestamp, source IP or domain name, destination IP or domain name, protocol information, and this would be the output of Wireshark. We can use Wireshark using a filter. For example, you can apply a filter that only captures the TCP packets or that only displays the DNS packets and so on. Wireshark has so many capabilities that can be used by professionals. Thank you.